We want to find the exact area under a normal curve for any point on the curve. In general, this is a very challenging calculus problem. However, normal curves are special. It turns out that all normal curves are the same. So what we'll do is transform an n mu sigma distribution to an n01 distribution. Draw a picture. Here is mu and here is some point x. Redraw the picture with mean 0 and a point z. We want the area above both x and z to be the same. The first thing we'll do is shift the curve to the left so that the mean becomes 0. This means subtracting mu from each point. Next, we want the standard deviation to be 1, so divide by sigma. This gives the z-score formula, x minus mu over sigma. This is called the z-score or the standardized score. It tells us how many standard deviations we are away from the mean. For example, given an n15-3 distribution and x equals 19, the z-score is 19 minus 15 over 3, which equals 1.33. So 19 is 1.33 standard deviations away from 15. How does this help us find the area? Well, consider an n24 distribution. What is the probability of a point less than 14? Draw a picture. Always draw a picture. Mark 20, make a vertical line at 14, and shade to the left. This does not need to be drawn well. In fact, only two things are important here. 14 is to the left of 20, and we shade it to the left. Compute the z-score, which turns out to be minus 1.5. A negative z-score is fine, it just means we're left of the mean. From here, we need to use a table. This is the normal distribution table. This table will always give you the area to the left. That's the purpose of this shading. This is convenient in our problem as we wanted the area to the left. To read this table, here are the first two digits of the z-score, and here is the hundreds digit. For example, this point would be minus 3.23, since z says minus 3.2, and the hundreds digit is 0.03. Our z-score is minus 1.5, which is this row. We didn't have a hundreds digit, so it's 0. Our area is 0.0668. We could write this as area equals 0.0668, but that doesn't tell us what we're finding. It's better to write this as p of x less than 14 equals 0.0668. This stands for probability of less than 14. That way we can remember and easily point to what we were finding. It's also fine to write this as a percent. Just be sure to write the percent. Let's do this again for greater than 17. Draw a picture and shade. Compute the z-score, this time it's minus 0.75. Go to our table, highlight the z equals minus 0.7 row and the 0.05 column. Our area is 0.2266. But is it? Look at our picture. We shaded to the right. Does that look like 22.66% of the curve? No, not at all. In fact, after 20 is 50% of the curve. Remember, the table gives us area to the left. Our actual answer will be 1 minus that number. So the probability of 17 less than x will be 0.7734. Notice inside I wrote 17 less than x. I like less thans because then I can see what side I'm shading on. The x is on the right, I shade on the right. This problem demonstrates why a picture is important. It helps us confirm that our answers make sense. Finally, find the value of x so that the probability that x is less than big X equals 0.8312. This problem is the previous two problems in reverse. We are given an area and we have to find an x. Draw a picture and label the mean. We need to be careful where we put our x. We want the area to the right to be 0.8312, so x will have to be on the left of 20. Shade and label the area to the right. Remember, our table gives area to the left, so find and label the area to the left as well. In our table, find the number closest to 0.1688. You find that in the big region of numbers because remember, we're given an area. The number closest is 0.1685. Highlight the row and column, so our z-score will be minus 0.96. Set up the z-score formula and solve for x. We find x equals 16.16. A very common mistake in a problem like this is thinking the area is a z-score and then using that z-score to find an area. That's why it's important to draw a picture and label it carefully just to remind yourself of what's going on, what information you need, what information you have, and you'll be less likely to make a mistake.